My name is Adam Lee, and this is the demonstration video for Lab 3. As we can see to the left here, we have a legend of the states as well as the corresponding LED outputs. To the right here, we have the state diagram as well as the transitions between each state. To begin the testing, we will try the progressive transitions between each state. So we have the machine that starts off in state 0 as denoted by my last name, LE, on the hex display. So if we turn on switch 1 and clock, we should go into state 1. So we will turn on switch 1. The corresponding LED for switch 1 turns on, and when we clock, we see that the machine does indeed transition to state 1, as denoted by the hex display as well as the LED output, which shows 001. Next, we will transition to state 2 with the input of switch 2. When we turn on switch 2, we see that the corresponding LED for switch 2 turns on, and when we clock, we see that the machine does transition into state 2 as denoted by the hex as well as the LED states, which show 010. Next, we will transition to state 3. Once we turn on switch 3, we see that the corresponding LED for switch 3 turns on, and when we clock, we see that the machine does transition into state 3 as denoted by the hex display as well as the LED state, which shows 011. And we also see that the output on these two LEDs shows 01, which matches the specifications of our state diagram. Next, we will transition to state 4. If we turn on switch 4, we see that the corresponding LED for switch 4 turns on, and when we clock, we see that the machine does transition to state 4 as denoted by the hex, as well as the LED display, which shows 100. We also see that the output shows 11, which matches the specifications of our state diagram. Next, we will test out the reset, which is switch 0. As soon as switch 0 turns on, we should see that the machine resets to state 0. And when we turn on switch 0, we see that the machine does indeed reset to state 0 as denoted by my last name. Next, we will try the transitions from each state to state 1. So we will go to state 2. Once we're in state 2 and we read the input switch 1, we should transition back to state 1. And when we turn on switch 1 and clock, we do indeed transition back to state 1. We will do the same thing for state 3. When we're in state 3 and read the input of switch 1 and clock, we should revert back to state 1. And when we do, we see that it does go back to state 1. Finally, we'll do the same thing for state 4. If we're in state 4 and we read the input of switch 1, we should go back to state 1. So we'll turn on switch 1 and we will clock, and we see that the machine does go back to state 1. Next, we will try the multiple switch condition. So if we are in state 2 and we turn on switch 3 and we turn on switch 4, since 2 or more switches are turned on, we should see that the state stays the same in this machine. So with these two switches, switch 3 and switch 4 turned on, and we clock, we see that the machine does not transition to any other state. Finally, we'll do the unspecified input condition. We see that state 2 only recognizes 2 inputs, switch 3 and switch 1. If we have, for instance, the input of switch 4 turned on state 2, which is unspecified, we should see that the state stays the same when clocked, and we see that it does. Finally, we'll see that the switch 0 resets from whatever state, no matter what the input is. So if we have switch 3 turned on, and we have switch 0 turned on, we should see that the machine resets to state 0, and it does.